Hello everybody and welcome to the Epic Flight Academy. My name is Mike Thompson and this is the Private Pilot Ground School course. Now, your success in this course is dependent upon three things. Number one, you must be studying Epic's online course. When you study that course, you're going to see a lot of references that you're going to want to refer to. Secondly, to be successful, these videos are for you to watch in parallel to that content. And the third key to your success is to review all of this content specifically one-on-one with your flight instructor. So we are so glad you're here. Today we're going to be talking about weather hazards. Now, as pilots, obviously, we're flying up into the atmosphere, and a little bit of knowledge about what these hazards are, when, where, and how they occur is pretty important to us. So we're going to talk specifically about thunderstorms, turbulence, visibility hazards, and icing. So let's get started with thunderstorms. Now, thunderstorms are all about air stability, and in particular, instability. Unstable air is a key factor in the formation of thunderstorms. In fact, for a thunderstorm to form, we need three specific things, and you can see those listed here. Number one, we need moisture in the air. Number two, we need unstable air. And number three, we need some type of lifting component. Now, in this picture here, you can see a line of thunderstorms, and it's running all the way from Louisiana up to Ohio. This is a long, powerful line of storms. Now, we studied air stability in an earlier aviation weather video here at Epic. That unstable air combined with moisture, and you can see in this picture, this system is going to draw a lot of moisture up out of the Gulf of Mexico. And then thirdly, that lifting component. And there's a couple of different things that can give that unstable air its initial lift upward. One of those might be a cold front. Another one of those might be what we call orthographic lifting. That just means that the terrain is rising and the air is lifting as it goes over that rising terrain. And a third common one is convective lifting. Now, you remember when we talked about convection, if there's localized heating, air will rise convectively. So those are the three requirements. Let's look at thunderstorms in general. You see that we might have an air mass thunderstorm. That's a thunderstorm that results from convective heating and convective lifting. We might also see a squall line. A squall line is a line of thunderstorms, and it does not necessarily need a cold front to help it develop. When you see a squall line on a chart, you're going to see it depicted this way. You see this a reddish or orange colored line, and it's a long dash with two dots, long dash, two dots. That depicts a squall line. And then the thunderstorms may also be what we call frontal thunderstorms. In that case, we have the classic cold front lifting warm, moist, unstable air in front of it. Now, when we talk about thunderstorms, let's talk about their life cycle. We generally speak of a thunderstorm life cycle in three stages. And you can see those stages depicted here from your left to your right. The first stage is the Cumulus Stage. Now, here we have unstable air starting to rise. And if we add moisture to that equation, we're moving into stage 2, which is the mature thunderstorm. Now notice in the center diagram here, the updrafts in this cloud, this cumulonimbus thunderstorm cloud, are separate from the downdrafts. They're passing each other. This is a mature thunderstorm cloud. And then notice all the way to the right, you see the third and final stage. That is what we call the dissipating stage. And notice here, those up and down drafts are not passing each other, but they're hitting each other. The downdrafts are in direct contact and conflict to those updrafts, and this thunderstorm is starting to cool. The air is starting to lose its instability, it's becoming more neutral, and the energy of this thunderstorm cloud is dissipating. Those are the 3 stages. Well, what about turbulence? This is another hazard that as pilots we want to be very conscious of. When we talk about turbulence, let's look at some of the major types. And you can see on our list here, we've listed 7 specific types of turbulence. The first one is mechanical turbulence. This is the result of air blowing around or over obstructions and or the geographical surface like hills or mountains. Now, mechanical turbulence can be felt as high as 3,000 AGL. The next one is convective turbulence. Now, we talked about convective thunderstorms, but without the thunderstorm forming, that convection alone will still cause turbulence. We sometimes call this thermal turbulence. The next one is called frontal turbulence. This is a fast-moving cold front, and when that cold front is moving along quickly, it may cause updrafts, and these could be in the range of 500, 600, even 1,000 foot per minute updrafts. So these can be pretty turbulent. Now, another type of turbulence is called wake turbulence. This has nothing to do with meteorology. This has all to do with the aerodynamics of the aircraft, and in particular its wings. Now, you're familiar from earlier lessons in aerodynamics that the wing has low pressure above it, high pressure below it, and we know from meteorology that high pressure wants to fill areas of low pressure. Now, because the aircraft is moving forward, that high pressure doesn't really have the chance to come over the front or the rear of the wing, and it attempts to come around the wing tips from from high to low. When it does that, as the aircraft continues to move forward, this wake turbulence makes these little vortices, or literally mini tornadoes, coming off the wingtips. Another type of turbulence is called clear air turbulence. Clear air turbulence happens when we have differing wind speeds up at high altitudes in and around the jet stream. The next type of turbulence is called mountain wave, and we find this on the leeward side of mountains. Now, what is the leeward side? The leeward side means the downwind side, and you can see that mountain wave depicted here in this diagram. We have stable air over the peak, but as the air flows over that peak, it causes this turbulent activity on the downward or leeward side. And then the next type of turbulence is called wind shear. Now, this can happen at any altitude. It could be associated with the front, or it could be just associated with an inversion in temperature. And wind shear is just air moving past each other. Some air is moving horizontally in different directions, or vertically in different directions, and as we fly through that shear in our aircraft, we experience turbulence. The final type of turbulence we want to mention and make you aware of is what we call the microburst. The microburst can be dry or wet. These come out the bottom of a large cumulonimbus thunderstorm cloud. And a microburst is the result of heavy cold air descending rapidly out the center of a thunderstorm or cumulonimbus cloud. Now, this microburst can have speeds up to 150 knots, so they can be quite violent. And when they hit the ground, they may spread as far as 2 or maybe 2.5 nautical miles. And so you might imagine that a dry microburst is just a downdraft of that air, and a wet microburst, well, of course, that is including rain and raindrops from this thunderstorm or cumulonimbus cloud, and it comes down rapidly in the center, hits the ground, and spreads out. So that talks a little bit about some of the types of turbulence. Now, let's get to our third hazard here for pilots while we're flying, and those are restrictions to our visibility. Now, I hope that you're thinking, hey, I'm going to get an instrument rating, and I'm going to be less concerned about visibility. Well, I'm glad you're getting an instrument rating, but you're not going to be less concerned about visibility. Visibility will be a concern to us whether we fly under visual or instrument flight rules. One of the things that restricts our visibility is haze. Haze is when the atmosphere picks up some dry, fine particles. And it really is exactly what it says. It sort of rounds off all the edges of our vision and everything appears hazy. Smoke is a restriction to visibility. Those of us who have flown out in the west, particularly in the summertime, if you've experienced forest fires and you have that heavy, thick smoke that blows downwind, that's a serious restriction to visibility. Smog. Smog is a fog-smoke combination and not uncommon around large cities. Dust, blowing dust and dust storms. This occurs naturally in the atmosphere as wind picks up loose, dry dirt particles and dust, sweeps them up into the air, restricts our visibility. And then we also have volcanic ash. All across North America and all across the continents, all across the world for that matter, are volcanoes. And when they erupt, they spew ash. And ash is a serious hazard to aircraft and a restriction to visibility. Finally, we have tornadoes. Now, tornadoes don't just restrict visibility. They come down out the bottom of a strong cumulonimbus cloud, or what we call a cumulonimbus mammatus. And across the bottom of this strong cumulonimbus cloud, you see these sort of ball-shaped pockets. That's called mammatus, and those are formed by violent down and updrafts within that cloud. If there is any rotational motion input to some of these up and down drafts, it's possible that one of those mammatus cells may develop into a tornado. You see a tornado depicted here on the screen. These are spinning columns of air descending from the base of that mammatus or funnel cloud. Now, these speeds may exceed 200 knots. So these are serious hazards that we don't want to be anywhere near. Finally, our fourth hazard is icing. So in addition to the references that are shown in our online course, I want you to be aware of additional references. And two additional references you need to be aware of are the AIM Chapter 7, that is the Aeronautical Information Manual, Chapter 7, where you're going to find information about these hazards, and when it comes to icing, an advisory circular 91-74. So in addition to the resources mentioned in your course, please be sure to review these resources. When you look at AC 9174 on icing, I want you to bear two critical thoughts in mind. Number one, ice will only form on the aircraft if we fly through what we call supercooled water. Now, what is supercooled water? Is it water that's cooled so cool that it's actually liquid below freezing? That would be supercooled? Yeah, you got it. That's it. If it maintains its liquid state below the freezing temperature, that is supercooled water. And believe it or not, that is entirely possible in the world of meteorology. The second thing that I want you to bear in mind as a pilot is that if and or when ice does form on your aircraft, it will start to collect and form around the smallest radiuses first. So think of the radius of your leading edge. Think of the radius of the leading edge of your horizontal stabilizer. Or think of the radius of the leading edge of an antenna. That ice will collect around the antenna first because it is a smaller radius. Your horizontal stabilizer second because that's a slightly larger radius. And it will collect on your wing last because that's the largest radius. Now, this is hazardous because we might not be aware that ice is collecting on our smaller radii, in particular our horizontal stab. When we come into land, we may be losing some of the downward aerodynamic force on that horizontal stabilizer and be set up for a potentially hazardous situation. So review that with your flight instructor. Now, this supercooled water is visible moisture. In order for ice to form, this visible moisture must be present. When it does form on our aircraft, I want you to think of the four forces: lift, weight, thrust, and drag. And lift will be decreased and weight will be increased, the exact opposite of what we want. Thrust will be decreased and drag will be increased, again, the exact opposite of what we want. So this icing that forms on the aircraft can potentially be very hazardous. It comes generally in three forms: rime, clear, or mixed. Now, clear ice is exactly what it says. It's when the aircraft hits that supercooled water and that water freezes clearly. Rime ice happens when some air is introduced into that freezing water, and when it freezes, it's cloudy. It's not clear like clear ice. It's cloudy, it's opaque. We call that rime ice. And then the third type of icing that we deal with is a mixture of the two of those together. Mixed rime and clear ice. Now, what about frost? Remember when we talked about latent heat and the fact that vapor could go directly to the solid state? Now, on a cool night, that's possible. You could come out to your aircraft in the morning and find frost on your wing. Think about that as a form of icing. Now, that frost layer is very thin, so you might be tempted to think, well, it's not that hazardous. In fact, the frost can be very hazardous because it will disrupt the airflow over that airfoil and possibly disrupt it enough to cause it to stall at speeds far below its normal stalling speed. You don't want that to catch you by surprise. Now, finally, when we talk about icing, let's take a look at our aircraft and understand that we have both de-ice and anti-ice systems. Now, de-icing systems are designed to remove ice after it forms. In other words, we let the ice form and then we de-ice it. Anti-ice systems, on the other hand, are designed to prevent the ice from forming at all. An example of that might be pumping warm, hot air into the leading edge of a wing and keeping that wing so warm that the ice won't form. That's an anti-icing system. On your aircraft, in the Cessna 172S model, you have a couple of de-icing systems. One is the pitot heater. Another is the window defroster. Once the ice forms, the pitot heat is electric, heats it up, melts it off, de-ices it, or the defroster pumps warm air up to the windscreen, heats the windscreen, defrosts it. So folks, those are the 4 types of hazards that we want to be conscious of. Let's wrap this up with a quick review question. What are the 3 things that we need for a thunderstorm to form? Number 1, unstable air. You got it. Number 2, moisture. Yeah. And number 3, that's right, some type of lifting mechanism. Well, folks, that's it for hazardous weather. We'll see you next time.